How you doing? Thank you for tuning in to this here video presentation by Mr. Larry Whittington, or as he want to be known, Mr. Whit. Mr. Whittington's know all about mathematics, and that is why he founded the Fort Bend Tutorings. Today we're going to learn about word problems. Not the kind where you curse people out, but the mathematical kinds. The kind I don't be understanding at all. Alright, get your ink pen and your pencil ready. Take notes, because you finna learn from Mr. Whit.
Hello, ladies and gentlemen. This is Mr. Whit with Fort Bend Tutoring, and today's tutorial is going to be about direct variation. That's right. Solving direct variation problems. And you'll see the direct variation problem set up just like this. That's right. It'll have the format of y equals k times x. And this format is usually read as y varies directly as x. This variable k that you see right here is called your constant of variation, and sometimes it's called the constant of proportionality. Variation problems can be solved using the formula method, and they also can be solved using the proportion method. However, for this video, we'll be using the formula method as we can easily solve for k when using the formula method. Also keep in mind that this is going to be a 4-part series. So throughout this video, you want to keep in mind that our constant k is also called our constant of variation, also the constant of proportionality, and that's going to be a value that many of our questions will ask us to solve for. So keep that in mind. So what does direct variation look like? Here, if you're simply looking at the format of y equals kx, you'll notice that this is a linear equation, which is a simplified slope-intercept form, aka y equals mx plus b. Notice that the b equals to 0. So our variable k is determining which way these lines are rising and falling. So for instance, if our k value is negative, we'll see the line rise to the left. If our k value is positive, you'll see our direct variation line rise to the right. So that is one way that we can expect the graph of direct variation to look like. However, it can also look like this. So this particular format reads y varies directly as the square of x. Notice that the similarity between the previous form and this one is that they both share the origin as a common point, that both graphs will go through the origin. And once again, these different colored graphs show the different graphs that would be formed depending on your value of k. For instance, if our value of k was negative, then all of these graphs would be pointing down. But for this graph right here, all the values of k are positive because I just didn't make any negative ones. Or you could say I was being lazy. Either way, these would all be positive k values. All right, just keep that in mind. All right, let's move on to number 1. So for number 1 here, we have the problem if y varies proportionally with x and y equals negative 1/4 when x equals to 8, A asks us to find the constant of variation, aka the constant of proportionality. Notice that sometimes the problem can read y varies proportionally with x, or it can also read y varies directly with x. Both of these phrases are referring to direct variation. So I'm going to start by setting up my initial problem as y equals kx. And since they've given us some information that we can use to solve the problem, in other words, they've gone ahead and told us that y equals to negative 1/4 when x equals to 8, we can go ahead and use those values using substitution to solve for our constant of variation. So I'll be replacing y with negative 1/4, and I'll be also replacing x with 8. Just like that. Once I have this set up here, I'm going to go ahead and solve for k. So in other words, I can divide both sides by 8 as it stands, or I can multiply both sides by 1/8, which I think may be a little easier. So I'm going to do that. So multiplying both sides by 1/8, I have 1/8 times negative 1/4 equals 1/8 times, and I'm going to go ahead and rewrite this as 8k. The same thing as k times 8. So now let's go ahead and simplify this. We'll see that 1/8 and negative 1/4 will multiply to give me negative 1/32. The 8's cancel out on the right side here, so we'll just end up with k. And this gives us our constant of variation. That's right. The constant of variation, the constant of proportionality. That's what our value k is. All right, so you know you got to red box the answer. All right, you just got to. All right, you got to protect that. Okay, it's yours. That's your answer. Put it in the box. So now that we have our constant of variation, the next part of the problem, all right, you want to look back at it? There it is. To find y when x equals 12. Now, there is something I would need to inform you about when solving direct variation equations, and that is many times the question will ask you for the variation equation. This is the equation that you can rewrite after you solve for your constant of variation. In other words, since I know that k is equivalent to negative 1/32, I can rewrite my original equation as y equals negative 1/32 x. Just like that. So because I know my value of k now, I can rewrite this equation using the constant of variation to complete the variation equation. If they ask you for the variation equation, that's what you see right here. This y equals negative 1/32 x. Let's use this to solve for part B. So now that I have my variation equation, I know I can go ahead and plug in 12 for x and solve for y. So let's go ahead and plug in 12 for x. We'll rewrite this as y equals negative 1/32 times 12. From here, you can go ahead and simplify the problem. So if we set it up as y equals negative 1/32 times 12 over 1, well, I'm going to choose to simplify before I multiply. And I know that 12 and 32 can both be reduced by 4. So that means I have 4 going into 12 3 times, and I have 4 going into 32 8 times. If I multiply straight across, I'll end up with y equals negative 3/8, and this is the answer to part B. All right, let's go ahead and red box it. Red boxing it. Just like that. And that's problem number 1. Let's go ahead and check out problem number 2. All right. In problem number 2, it says if c varies directly as the square of d and c equals to 12 when d equals to 6, find the constant of variation, and also they want us to find c when d equals 9. So the first thing I want to do is I want to set up my problem using the format of direct variation. Notice that in this problem, we no longer are using x and y. That's okay. All you want to do is use the format to guide you through the problem in your setup. You won't always be using x and y in your equation, so don't freak out if you don't see those variables in the problem. So we'll be setting up our equation as c equals k times d squared. As it states in the problem, c varies directly as the square of d, so that's why we have it set up that way. Now we're going to find our constant of variation, our constant of proportionality. And we do that by plugging in the given information here that c equals to 12 when d equals to 6. All right, so let's just check that out. We're going to be replacing c with 12, and we will replace d with 6. All right, solving for k, we'll have 12 equals 36k, and then I'll be dividing both sides by 36. Go ahead and get that division on in there. All right. And so simplifying our 12/36, we can reduce both 12 and 36 by 12. So we know that 12 goes into itself once, right? And 12 goes into 36 3 times. So we simplified the k value to 1/3. All right. That's our constant of variation. That's the answer to part A. Okay, using our constant of variation, we can rewrite the variation equation as c equals 1/3 d squared. And this would be your variation equation if the problem asks for it. Either way, we're going to be using this variation equation to solve part B of problem number 2. So part B requests us to solve for c when d equals 9. So we'll do just that by substituting. I'll have c equals 1/3 times 9 squared. Like so. From here, we'll simplify the equation to solve for c. I'll have c equals 1/3 times 81. Knowing that 1/3 is the same thing as dividing by 3, we'll have 81 divided by 3, which is 27. That's right. Or you can say 3 goes into itself once, 3 goes into 81 27 times, then multiply and simplify to get 27. Yeah. 27 is the answer. Red box it. Red boxing it. And that's problem number 2. Not bad, right? Not bad at all. Let's check out problem number 3. In problem 3, we're provided with a table. And the question says, in the following table, y varies directly as x. So if I was to set up a variation equation for this, I would have y equals kx, just like so. They're asking us to use the table to find the constant of variation and to write the equation that shows that y varies directly with x. And in between all of this, we probably can go ahead and complete the table, right? So let's see what happens. If I start out by plugging in 2 and I end up with 8, what occurred in order to get our result of 8? Let's say we can find a pattern. So we plugged in 2, we ended up with 8. And then they plugged in 3 and ended up with 12. They plugged in 4. They ended up with 16. So we need to find out what's going on here. All right. And what I'm thinking is going on, especially since we're dealing with direct variation and something is multiplying on our value of x, we can tell that each input of x is being multiplied by 4. Because 2 times 4 is 8, 3 times 4 is 12, 4 times 4 is 16, 4 times 6 is 24. Therefore, completing the table, 8 times 4 is 32, 12 times 4 is 48, and the reverse can be done to find out our value of x. In other words, 80 divided by 4 gives you an input of 20, whereas 120 divided by 4 gives you an input of 30. All right, so that completes the table. If we need to find the constant of variation, it's what we've been multiplying everything by, or dividing by for that matter. And that means that our value of k is 4. It's 4. We've been multiplying everything by 4. That's right. So the constant of variation, the constant of proportionality, it's 4. Now, for those of you that couldn't see from the table that we were multiplying everything by 4, what you could do, you could take one input and one output. For instance, you can use the value of x as 2 and use the value of y as 8 to solve for your constant of variation, showing that I would have 8 equals k times 2. All right. Then solving for k, we would divide both sides by 2. So therefore, our constant of variation, once again, comes out to be 4. And as always, red box it. All right. So now that we have part A taken care of, they're asking us to write the equation showing that y varies directly with x. This request is asking you for the variation equation. So all we have to do is take our constant of variation and plug it back into the setup of the problem that we have right here. This y equals kx, go ahead and replace our constant of variation in for k. So our answer will read as y equals 4x. And that's it. That's the variation equation. That's the equation showing that y varies directly with x. Done. Red box it. All right. And keep in mind that you need the entire equation to represent that variation equation. Don't submit an answer of just 4x. You need to write the entire equation in for the answer. Y equals 4x. And that's problem number 3. Let's move on. In problem number 4, we have Hooke's law says that the distance a spring is stretched varies directly as the weight of the object attached to the spring. A 5 kilogram weight stretches a spring 35 centimeters. In part A, they want us to find the constant of variation. And in part B, it asks, if a 3 kilogram weight is attached to the spring, how far will the spring be stretched? Well, let's find out. So since it says a distance a spring is stretched varies directly as the weight of the object attached to the spring, I'm going to use D for distance, my constant of variation, and I also use W as the weight of the object attached to the spring. I'm going to go ahead and use the values that are given to me, and it says that a 5 kilogram weight, all right, stretches a spring 35 centimeters, so I have 35 here for my distance. Solving for my constant of variation, I can divide both sides by 5. Oh, that is an ugly 5. Do you want me to fix that? All right, okay, all right. I'm going to fix it. I'm going to fix it because it's ugly. This is better, okay? That's as good as it's going to get for now. So simplifying this, we now know that 35 divided by 5 is 7 to tell us that our constant of variation is 7. Yeah, the constant of variation is 7. That's part A. Red box it. Red box it. You got it. Part A is done. For part B, we're going to need the variation equation to complete the problem. So our variation equation is going to be the distance equals 7 times the weight. Now we have our variation equation, and we can use this to solve the next part of the problem. Part B says if a 3 kilogram weight is attached to the spring, how far will the spring be stretched? So all we have to do is plug in the following information. 3 for the weight. So our distance equals 7 times 3. 7 times 3 is still 21, right? So it's going to be 21 centimeters. That's it. That's the answer to problem number 4. Red box it. Get your red box on. Here we have problem number 5. And in problem 5, it says the distance x an object falls from rest in t seconds varies directly as the square of t. If an object falls 144 feet in 3 seconds, A, how far does it fall in 5 seconds? And B, how long does it take to fall 784 feet? Let's find out. So we'll start off with our variation equation. The setup for it will be x equals k times t squared. The distance x an object falls from rest in t seconds varies directly as the square of t. This is exactly what I have right here. My distance is x, and I have my constant of variation multiplying on the square of t, in other words, t squared. So we'll use the information given in the problem to solve for our constant of variation. So I know based on the given information that the distance is 144. I don't know my constant of variation, but I do know that the time is 3 seconds, and that is to be squared. Solving for this, we'll have 144. This equals 9k after squaring our 3. To solve for k, our constant of variation will be dividing both sides by 9. And once we divide by 9, we find that our constant of variation is 16. The constant of variation is 16. We're going to use this value of 16 to come up with our variation equation. So the variation equation will now be x equals 16 t squared. This is the variation equation that we can use to solve part A and part B. So for part A, it says how far does it fall in 5 seconds? Go ahead and replace your value of t with 5. So I'll have x equals 16 times 5 squared. All right. Then simplifying this, we'll have x equals 16 times 25. And multiplying 16 times 25, you'll end up with 400. So the answer is 400 feet. That's part A. Go ahead and box it up. Red boxing it. All right. Part B says how long does it take to fall 784 feet? Well, let's find out. And so once again, I have my variation equation, x equals 16t squared. And for part B, we want to find out how far does an object fall when it falls 784 feet. So here, I'm going to rewrite my variation equation to find out what this time is. We'll start by dividing both sides by 16. Once I divide both sides by 16, I have t squared equals 2. Dividing 784 by 16, we end up with 49. And finally, to solve for t, we'll be taking the square root of both sides of the equation. So I'll have the square root of 49 equals the square root of t squared. And we'll just need the principal root, aka the positive root of this problem, because we're dealing with real life. You can't go back in time, guys. Therefore, the square root of 49 is 7. And we only need the positive version of 7 here. All right. And once again, it's because we're dealing with real life and no one has a time machine yet. So 7 seconds is how long it'll take an object to fall 784 feet. 7 seconds it is. So you know what? Let's go ahead and make sure we have that unit of measurement in there. 7 seconds. Red boxing it. All right. So coming up, we have our last problem. All right. For problem number 6, it says the stopping distance of a car is directly proportional to the square of the speed of the car. A, if a car traveling 50 miles per hour has a stopping distance of 170 feet, find the stopping distance of a car that is traveling 70 miles per hour. All right. And B, it says if it takes 244 and 8/10 feet for a car to stop, how fast was it traveling before the brakes were applied? So let's go ahead and start out with setting up our variation equation here. So I'll set up the equation as the stopping distance equals to the constant of variation times the square of the speed of the car. All right, so I have d equals k, my constant of variation, times s squared, and I'm using the variable s as the speed of the car. So for starters, I'll be plugging in the information in A to solve for my variation equation. It says if a car traveling 50 miles per hour, so the speed is 50 miles per hour, and that'll be squared, has a stopping distance of 170 feet. From here, we can go ahead and solve for our variation equation, right? So I have 170 equals 2,500, because 50 times 50 is 2,500 K. We'll then divide both sides by 2,500 to solve for our constant of variation. The 2,500s will cancel out, and my constant of variation can be simplified here. All right, let's simplify this. We know that it can be reduced by 10, and then that's it. We're going to end up with a constant of variation of 17/250ths. All right, that's ugly, but it's correct. So I'm going to rewrite my variation equation as the distance equals 17/250ths s squared. That's our variation equation. Let's use this to finish part A. So for part A, we're asked to find the stopping distance of a car that is traveling 70 miles per hour. So we'll go ahead and plug in 17/250 times 70 squared. We know we have our constant of variation times 4,900. That's the result of 70 squared. And then we're going to simplify this. I know I can reduce the 250 and the 4,900 by 10, and so we'll end up multiplying 17 times 490 and dividing that by 25. After simplifying everything, you'll end up with 333 and 2/10 feet as your stopping distance. All right, that's part A. Red box it. Yep. For part B, we're going to use the same variation equation, as they didn't give us any different information to solve part B. So solving part B of problem 6, if it takes 244 and 8/10 feet for a car to stop, how fast was it traveling before the brakes were applied? We're going to replace our D with 244 and 8/10, and we're going to solve for our speed here. I'm going to start by multiplying both sides by the reciprocal of our coefficient. So I'm going to multiply both sides by 250/17 times our 244 and 8/10, and multiplying the right side by that 250/17. That'll allow me to cancel out that right side coefficient of 17/250ths. All right, so right side, everything cancels out. You'll just be bringing down s squared. As far as the left side is concerned, we can go ahead and find out what this value is. So multiply the 250 and the 244 and 8/10 together, then divide by 17. That's one way to do it. You'll end up with 3,600. All right. You'll then take the square root of both sides, remembering that we just need the principal root, aka the positive root. So the square root of 3,600, you'll end up with 60 miles per hour as the speed that the person was traveling before they applied the brakes. And this is the answer to part B to problem number 6. Red boxing it. Just like that, ladies and gentlemen. This has been Mr. Witt with Fort Bend Tutoring. As always, please rate, comment, and subscribe. And if you're able, please click on that support button and give us a donation, as that helps us bring you more free math tutorials from Fort Bend Tutoring and Mr. Witt. Peace.
We're going to be learning about such things as linear, quadratics, system of equations, tables, mixtures, work, oh Lord, distance, interest, of which I don't have much, investment. This is my favorite one. I'm going to name my grandbaby consecutive integers, algebraic translations, and percents. I understand a little bit about percents. I know that 50% off is pretty good.
I'll have 3x minus y is greater than or equal to 3. I'm going to solve for y by subtracting 3x to both sides. I'm just showing my work here. That's all I'm doing. I mean, I would do it anyway without you.